My name is Brianna Walker. I'm 16 years old and a junior at Dove Science Academy. Today I'm going to be talking to you and explaining the physics behind my PBL project, watermelon versus rubber bands. The basis of this project is actually really simple. All you really have to do is get rubber bands and a watermelon and put the rubber bands on the watermelon until it explodes. This experiment mostly relies on the watermelon. If you have a small round watermelon, it's going to take more rubber bands. If you have a large oval watermelon, it's going to take less rubber bands. Another part of the experiment is the concepts of elastic and inelastic deformation. If you push something, it moves. You remove the force, the thing returns back to its original position. If you push something, but then you remove the force, it doesn't come back to the same shape. You broke the bonds, material moved and flowed, and you created a different base state in the process. When you add a rubber band, there is force applied to the watermelon surface at the microscopic level. The surface deforms a slight bit, with layers of molecules doing a combination of moving closer together, which is compressing their bonds and raising potential energy. You keep adding the rubber bands. It's a one-by-one process, a really slow process. So there is some time for the materials to physically respond to the small changes in force, moving slightly. The surface keeps on sagging, some of the resistance forces from the pushback of the compressed bonds under the bands. As the compression increases, the force displacing the rind is also transferred into the liquid. So basically, the more rubber bands that you add in the same place is going to build up the pressure in the watermelon, making the watermelon explode. If you have rubber bands kind of all over the watermelon, it's going to take more rubber bands because you're not putting them on top of each other, making the pressure more into one area.